Hey guys, coming at you with an exciting video about math. Alright, we're going to do part 3 of 3 of trigonometry, angle of elevation and angle of depression. Trigonometry is a very useful math. It's very applicable in the real world. Just an example, as I've been mentioning, your furniture, your buildings and your structures, anything complex that's standing straight up would not be doing so if it was not for trigonometry. It's a very, very useful math. It gets used all the time. Let's get started. So we're going to do a definition of trigonometry. We're going to talk about the 3 ratios that we're going to be working with in trigonometry. Then we're going to do 4 word problems involving angle of elevation and angle of depression. So let's get started. Okay. Definition of trigonometry. Trigonometry is a branch of mathematics dealing with the relations of the sides and angles of triangles. In our case, specifically right triangles. Now, you'll notice here that this is a triangle inscribed in a circle. Well, truth be known, right triangles, or triangles in general, and circles are cousins of each other. And trigonometry, as it gets into much higher levels, involves how a triangle exists inside a circle. And then beyond even that. So, let's get started with the ratios of the right triangles that we're going to be using. So, here we're just using 3. There's 3 others that we're not going to cover. That's for that advanced stuff that we're talking about there. So we have the sine of theta, which uses the opposite and hypotenuse sides of a right triangle. We have the cosine of theta, which is the adjacent and hypotenuse of a right triangle. Then we have the tangent of theta, which uses the opposite and adjacent sides of a right triangle. Theta, that symbol there, is just a Greek letter that is often used to represent a reference angle. And opposite and hypotenuse of a specific angle provides a ratio that's constant. So we can use that constant ratio to solve right triangles. That's where these ratios came from a long, long time ago. So now let's put them to use. So we're dealing with the definitions of angle of elevation and angle of depression. So we're going to start with this word problem. So a fire ranger is on a lookout tower at a national park. His observation position is 215 feet above the ground when he spots an illegal campfire. The angle of depression of the line of sight to the campfire is 3 degrees. How far is it from the campfire? So let's take into real consideration here. This could be a serious concern in some dry areas. And that person is going to need to provide a person that's down here at the base some direction to and distance to get to that person as quickly as possible to put that fire out. Angle of elevation and angle of depression. So this is the angle of elevation here, looking up. This is the angle of depression here, looking down. Let me label those. So depression, elevation. If you look closely, you may notice that these are alternate interior angles. So that means that they're equal. So this here is 3 degrees, and this here is 3 degrees. Now, we want this distance down here. So let's use blue. So we want this distance down here. Okay? So this angle here, it's not that useful. But this angle is. I could use this angle to calculate my distance. I know that the tower is 215 feet tall. So now let's do this. So this is opposite. This is a right angle here. It doesn't look like one because of the way the diagram is drawn. They do that on purpose sometimes to throw you off. So that's the hypotenuse. And this is adjacent. And looks like here I'm going to be using tangent. So let's take a look at the three ratios. So I have SOHCAHTOA, which is the abbreviated version of the trig ratios. And tangent uses opposite over adjacent. So let's do that. So I'm going to say tangent 3 over 1 equals opposite 215 over x. Just so we have it written, that's opposite over adjacent. So I just plugged in right into that. The angle always goes with theta. Opposite 215, adjacent is x, so now I can solve. So now I'm going to cross multiply. 1 times 215 is 215. X times tangent 3 is tangent 3 times x. So now I'm going to divide. So I'm dividing tangent 3 out so then I can get x by itself. Respect, tangent 3 is a number. So if I plug into the calculator just tangent 3, that's that number right there, 0.0524, blah, 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 blah. Okay? It's the ratio that exists between these two sides. I'm using that number to find the missing side because the calculator already knows what the ratio is. Okay? Because it's constant, always at 3 degrees. So now I'm going to plug that in. 215 divided by tangent 3. And I get quite a large number, which makes sense because this is a very narrow angle. So that means you got to think if we're 215 feet up, I'm only looking down 3 degrees. That's very, very little. 3 degrees is really, really small if you just look at a protractor. So it makes sense that it's a huge distance. And I believe that's feet. Okay? Alright, so that is that problem. Alright, let's take a look at the next one. Okay, a pilot of a plane is flying at an altitude of 18 kilometers and is getting ready to land. He spots the airport of an angle of depression of 10 degrees. Find the actual flying distance to the airport. Okay, so I'm going to have to draw a right triangle here. Because this is like my airport, that's the ground, and here's my airplane. So if that's my airplane flying down this way, it gives me the angle of depression. Now we learned that angle of elevation and angle of depression are the same. So that means I can just put 10 degrees down here. And what's the actual flying distance? So the plane is not going to fly down, then on the ground, drive, or roll to the airport. It's going to fly this way. So that's x. And then the airplane's 18 kilometers high. Alright, so I'm going to take a look at SOHCAHTOA. SOHCAHTOA. I'm going to label. So that's my opposite, and that's my adjacent. Ooh, look at the mistake I almost made. That's hypotenuse, and that's adjacent. I have my opposite side, leg, side, whatever you want to call it, and I'm looking for my hypotenuse. So I'm going to have to use sine. So sine of theta is equal to O over H. The angle is 10 degrees, so I'm going to put that where theta is. 18 over x. I'm going to cross multiply and solve. So 1 times 18 is 18, and then x times sine 10. Cross multiplication makes this process a lot easier. Is it more steps? Yes. But it's less confusing than trying to remember, in my opinion, when you're dividing or multiplying trig functions. It's much harder to memorize things, but if you can use something you already know how to do in your favor, such as cross multiplication, you're making your life a lot easier. Is it more steps? Yes. But you do trig for a little while, then you memorize when to divide and multiply. But then you let it go for a couple of months. Then you go back. And then you forgot. Okay? Because when we memorize things, that's not a long-term solution. That's a short-term thing. Using stuff over and over and over again, such as cross multiplication, then applying it somewhere to different types of math functions, such as trig, that's a whole lot easier to remember. So now here I have my answer, 103.66. That's kilometers. And that's the distance that plane needs to fly to get to that airport. All right, let's go to the next one. Moving along. We got 2 more. And they are whoppers of problems. So let's take a look. Chris and Logan are on opposite sides of a 160-meter tower. The angles of elevation are 40 degrees and 55 degrees respectively. Find the distance between Chris and Logan. Well, 160 meters is the tower. Chris is at 40 degrees, and Logan's at 55. That's just reading the problem when it said respectively. I'm going to tell you the truth in the end. It really doesn't matter where you put that angle, and you're going to see that. So this is a trig problem, so I'm going to have to use SOHCAHTOA. But I have to find 2 distances and add them together. Let's see if I can do this without making a mess smudging it. I'm going to find the y first, so then I can keep it on that side. So that's opposite. There's the hypotenuse, and there's adjacent. Okay. Well, they gave me the opposite leg and want me to find adjacent, so I'm going to use tangent. So tangent theta is equal to O over A. Let's plug into that. Tangent 55 over 1 is equal to 160 over x. Now I'm going to cross multiply and solve. X times tan 55 equals 160. When I multiply that, then I divide to get x by itself. Tangent 55 divided by tangent 55 is 1. And let's see what the calculator says the answer is. So I have 160 divided by tan 55. Okay, I have 112.03. I always like to go back to decimals. For most word problems, that's accurate enough. All right, let's take a look at this one. Well, I draw the arrow that's also opposite of 40 degrees. This is the hypotenuse, and this is adjacent. So I'm going to be using tangent again, because they gave me the opposite leg, and I need to find the adjacent leg. So tangent of theta is opposite over adjacent. Okay, so opposite leg is 160, and my angle is 40. That's 160 over x. I'm going to cross multiply again. And you may notice that I'm going to end up with the same result. That's typical of these double right triangles. So if you want to skip steps, you can. But I'm not going to do it here for your viewing pleasure. So now, from there, I'm going to punch that into the calculator. 160 divided by tan 40. 160 divided by tangent 40. And that's 190.68. So I need this entire distance here. So what I'm going to do is I'm going to add those two answers together. So let's get this out of the way. So 112.03, then 190.68. So let's do that. Put that right there. So 112.03 plus 190.68. 302.71. Okay, to the next problem. And the last problem. So now, from the top of a 100-foot tall building, a man observes a car moving away from the building. If the angle of depression of the car changes from 6 degrees to 2 degrees during the period of observation, how far are the cars? So let's take a look. Okay. So it says 2 degrees and 6 degrees. Again, don't get too caught up in how you're going to label this, the degrees. But I could tell you this. The more upright an angle is, the larger the number is. So this will be 2 degrees, because this is a little bit more narrow, and that's a little bit wider, so that'll be 6 degrees. Then the building is 100 feet tall. Okay, so now I'm going to look, before I even label it, I'm going to write SOHCAHTOA on the board. And then I'm going to label it. So, this is opposite of both of these, right? So that's opposite. Now this is the hypotenuse here, and the hypotenuse here. Let's not get too caught up on how ugly this can get. But this is adjacent. I'm going to call that X. And then this is my other adjacent side. I'm going to call that Y. And I'm going to have to subtract these because in the end, I want this distance. So let's get started. I'm going to do X first. So opposite and adjacent, that's going to use tangent. So tangent theta, opposite over adjacent. So tangent 6 equals 100 over X. I'm double checking my word problem to make sure that I'm using the right numbers. I'm going to put a 1 under here and cross multiply. So that's 100 equals X times tangent 6. I'm going to divide to get the answer, and let's see what I get. So 100 divided by tangent 6. And that's 951.44. 951.44. All right, let's do Y. So again, it's opposite over adjacent. As I mentioned in the other problem, most double triangles that I've done involve the same trig ratio. In fact, they involve pretty much the same setup. So that's 1. So now I'm going to cross multiply and solve. So I have 100 equals tangent 2 times X. I'm going to divide by tangent 2. Tangent 2 divided by tangent 2 is 1. Now we have to see what 100 divided by tangent 2 is. Okay, on this calculator, I have the opportunity to just press up. I don't have to type the whole thing over again. And you may have noticed I switched between fraction and division. Remember, fraction and division provides you with the same operation. The calculator, though, may handle it slightly different. So keep that in mind. Now I have to subtract these two. So 2863.63 minus 951.44. And let's see what I get. So 2863.63 minus 951.44. And I get 1912.19. In short, let's just compare these two problems real quick before we go away. If we look at these two, a simple way to look at it is you have to do two trig processes no matter what. But when they're in opposite directions, you add them. When they're in the same direction, you subtract them. And also notice here we use the angle of elevation, and here we use the angle of depression, and in both cases the angles are at the bottom or in the same place. So that's part of the beauty of knowing when something is alternate interior and congruent or equal to each other. Alright guys, I hope you guys found this video on the part 3 of the trigonometry videos and the angle of depression and elevation helpful.